My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. Our guest on AutoVision News Radio this time is Joe O'Hare, Senior Director of Marketing at Everspin Technologies. Joe has had a rewarding career in the semiconductor industry at companies like Texas Instruments and Lucent Microelectronics. Over the years, he has held a variety of engineering, marketing, and executive positions with a focus on developing products for the storage industry, both magnetic and solid state. And at Everspin Technologies, Joe has held roles in sales and marketing since 2011. After sitting down with Joe for a learning session on MRAM, I found that Everspin is more than just a cool name for a company, and though it is that, it refers to the usage of spin transfer torque technology, sometimes abbreviated as STT, to read or write an MRAM cell. What was most interesting about my time with Joe is how I learned about the many applications of MRAM: aerospace, robotics, medical devices, AI, manufacturing, and automotive. And with the rate of change in the automotive industry and the inflection points around software-defined cars and electrification, MRAM plays a critical role in facilitating the future of transportation. To begin, Joe provided us with an overview of Everspin and their focus today.
We were established back in 2008, so we've been around for a while. Even though we think of ourselves as an emerging technology company, we've actually been at it for quite a while. And the origin of the company is that it started out as research effort within Motorola Laboratories. That became Freescale Semiconductor. Freescale made the decision to spin out the company so that it could pursue the commercial business of designing, manufacturing, and selling magnetoresistive memory, which is really the core of our business.
As I have sought out more information on how MRAM works since I recorded this with Joe, I found an article by Robert Sheldon and Rodney Brown from TechTarget. See the link in the show notes. Sheldon and Brown write that even though large companies have invested in MRAM, smaller entities like Everspin have developed some of the most notable advancements with regard to MRAM technology.
Everspin is actually in high volume production of MRAM, and probably, from what we can tell, still the only company that has been successful in commercializing the technology in this kind of volume. And we're very proud of that. And that comes from really a legacy of having the innovation around the MRAM technology itself, what it takes to build a memory product, and the ability then to do that in high volume, where we've made a distinction for ourselves. Where the product has found a very good home is in the area of embedded systems, where particularly for electronics, for industrial systems, where the robustness and the overall strong reliability of the technology has been of great value to our customers.
Yeah, that's fantastic, Joe. And now, good time as any to ask the million-dollar question. What is MRAM? How would you describe it?
Right. Yeah. So MRAM is really short for magnetoresistive RAM. RAM being random access memory, which is the common memory used in most computing systems today. The uniqueness of MRAM is that the data stored in the memory is actually stored as a magnetic state, which is different than conventional memories, which store data as electrical charge. And the beauty of storing it as a magnetic state is that it doesn't go away when the power is removed. It is what we call a non-volatile or persistent memory, whereas alternatives such as DRAM or SRAM, which are commonly used in most computing systems, they lose their data when the power is turned off. The other unique factor in MRAM is that it has the ability to sustain many write cycles. We're talking billions of write cycles, whereas other alternative technologies that are non-volatile, such as NAND flash or NOR flash, typically wear out in just a few thousand or maybe up to 10,000 write cycles. So now you have a memory that has random access capability, i.e. RAM, but you can also write to it so many times that it can be used in standard memory workloads in computing systems. And that's where we have excelled. So MRAM today is deployed in all types of systems across the gamut of different types of segments, and that being in servers where our memory is used as a journal memory for the RAID systems, in industrial systems where our memory is used as a storage place for the key manufacturing setup parameters that are used in a process automation line. Same is true in robotics, also in many types of systems that are endpoints collecting data in the IoT. So if we think about sensors gathering all types of physical parameters, that data needs to be stored quickly and it needs to be protected in the event of power loss. And that's where MRAM comes into play very well.
Something I enjoy is going through media briefing decks. And for any marketing and PR professionals that might be listening right now, just know that a good media briefing deck with lots of helpful information is the way to my heart. And in Everspin's media kit, there was a slide labeled Core, Edge, and Endpoints, and I asked Joe to help me get my mind around these things.
When we think about how data is processed and stored, it really begins at the core of the network. And the core of the network is referring to the very large scale, high connectivity, high bandwidth systems that we think of when we think of the major telecom providers and the major ISP providers and the data centers that go with them. And in that core, because of the degree of connectivity we have, many enterprises have moved all of their own data processing into the cloud, which is another term that overlays this network. And in that cloud environment, now you have mega centers that are processing and storing the user data of both enterprises, right down to individuals. And there we think about very large systems that are enterprise in nature, which have, certain types of performance and reliability requirements. From a network perspective, you have to get from that core out to the individual users. And along that process, there is what's termed the edge of the network. And it's at the edge of the network where then you get a much more distributed type of processing and communications. And if you think about cell phones, for example, we connect to the cellular network through a base station. That's the edge of the network. And then that communications traffic is processed to wherever it needs to go across the world. And that's the core. The internet, is kind of the backbone of all of this data path and data communications. And the internet has now reached out to individual users. And that is the IoT, the Internet of Things, as it's been called. And in that, you have endpoints in which there is now very local processing and very local equipment in the sense of either, again, in the analogy of cell phones, but you can also think of it at the industrial level where everything that is being processed can be monitored at an aggregated level. We think about smart cities, for example, where now residential homes have smart meters that define what type of usage is going on in a given place. That is, brought to the edge of the network, processed locally and regionally as needed, but also can go back to the core and monitored and tracked there for all types of enterprise purposes.
Staying with Everspin's media briefing kit, I was able to get a general idea of the fundamental aspects of MRAM: performance, endurance, retention, low power, and unified memory. Super important concepts that, at this juncture, being new to MRAM, are coming at me like a fastball. And luckily, Joe was there at the bat to drive these concepts home.
It has to do with the things that MRAM does really well, and that is endurance, meaning how many times can you write to the memory before it wears out. We talk about power consumption and the fact that we write at relatively low energies. The devices can be used both in powered and in battery operated systems. and data retention, which is how long the data will stay in the memory when you have either power on or power off. And for non-volatile or persistent memory, you need to be able to store data for many years. And, we tout 10 years and in some cases 20 years, depending on the use case of data retention capability. So the user doesn't have to worry about losing their data for very long periods of time. This concept of then unified memory, because now you have a device in MRAM that has the speeds of random access memory, but the long-term retention capability of data storage that you typically find in things like SSDs or hard disk drives. Now, I will clarify that our memory devices, from a memory density standpoint, we're not on the highest capacity points that you achieve with other technologies like NAND, which is used primarily for data storage. But in some of the endpoints that we refer to, the data sets are not that large. And that's where there is an opportunity in these embedded systems to think about using one type of memory for different types of storage and memory workloads. That's the concept of unified memory. And it's all of these things that MRAM does so well: the endurance, the data retention, the RAM-like random access performance, allowing for unified memory, all being done at relatively low power and energy use.
If our first $1 million question was what is MRAM, our second $1 million question is how does it apply to the vehicle?
Particularly exciting is the electrification of automobiles and EVs. There is just a tremendous amount of local data being processed. There are hundreds, if not thousands, of data collection points in a given vehicle, in a single vehicle. And they can range from things like event recording, and, God forbid, in the event of an accident, those things are recorded. MRAM can be used in that case because of its very fast writing capability and the ability to store that data without power in a very efficient way. But there are other things that are in the vehicle, such as the personalization of the cabin, meaning, what type of environment you want when you're sitting in your vehicle. That goes all the way from, the entertainment choices to the environmental choices, and then your own driving habits. And these systems are now personalizing that for each individual driver. In the case of electric motors, you have very large batteries which drive these, but they do actually operate under much higher voltages, and they create an inversion process. So in these inverters that are in all the electric vehicles, they have found that, MRAM is a good way to make sure that all of the parametrics are optimized and being compared against, what the vehicle is supposed to be doing. They can store that data in MRAM quite easily.
Here we have our finished product, the vehicle, equipped with value-inspired features that resonate with customers. What's neat about MRAM is how it's not only contained to the car itself, but rather it can be a fundamental part of how all of the components come together.
Really, our legacy as a company has been in supplying to the industrial electronics world. And in that case, there are manufacturers of the process automation control systems that basically run manufacturing lines for all types of manufacturing, including vehicle production. In addition to the process automation control line, there are individual robotic instruments, of course, being used to build various aspects of the vehicle as it moves along. So it's kind of interesting that in that regard, all the way to the actual original manufacturing of the vehicle to its deployment out in the field and the use by, you and I, MRAM has a role. In the case of programmable line controllers or logic controllers that are used for process automation, each manufacturing line is going to have a set of setup requirements for whatever they're producing, at that time. And then there is some type of also human interface that has to happen between the manufacturing line people and the automated equipment. And in those cases, also, those devices use MRAM as well. And they really love the fact that we have very high temperature capability, that we are able to store data for very long periods of time so that manufacturing setup parameters can be recalled either for what you want to run today or what you might want to run a few years from now when that production line is still running. You can go back to it because the data is stored without any loss of data integrity in the MRAM.
During the conclusion of our chat and my introduction to MRAM, I asked Joe to share his thoughts on Everspin's design wins.
Good success more recently, and we have been public about that and announced last year that Lucid Air in their vehicle is using our product. And also more recently, a company called Rimac out of Eastern Europe, which is also building electronic systems for EV makers such as Bugatti. So in both these cases, we have those that are building on the highest end of high performance electric vehicles, both from a performance and luxury standpoint, using our MRAM. What's exciting to us is that we do believe that, when you look at what they're putting into these vehicles for high performance and for luxury is something that will be more commonplace and adopted as kind of the standard offering, for vehicles of tomorrow. And it's that kind of progression that we believe with some of the early pioneers adopting MRAM that, give us a belief that there will be a much wider adoption of MRAM in electric vehicles in the future.
For more information on Everspin technologies, visit everspin.com. That's everspin.com. You can also keep up with the Arizona-based company on LinkedIn. AutoVision News Radio is available on Spotify, Apple, iHeart, and more. In Detroit with Joe O'Hare, I'm Carl Anthony, AutoVision News Radio.